Walk into any golf shop in America, pick up 2 irons from the display rack, and ask the guy behind the counter which one feels better. If one of those irons has the word forged stamped on the sole, 9 times out of 10, that is the club he is going to put in your hands first. He will tell you about the buttery feel, the pure feedback at impact, the way a properly struck forged iron sends a sensation through your fingers that cast metal simply cannot replicate. He will use words like soft and responsive and connected. And honestly, he might be right about all of it, but he also might be selling you a story that the golf industry has been telling for decades without ever being forced to prove it under controlled conditions. The forged versus cast debate has been splitting golfers into two camps for as long as modern club manufacturing has existed. On one side, you have the purists who believe forged irons are the only real option for anyone who takes the game seriously. They speak about cast irons the way vinyl record collectors speak about streaming music, with a mixture of pity and disdain. On the other side, you have the engineers and data analysts who argue that casting technology has advanced so far that the distinction barely matters anymore, that the measurable differences between the two processes have shrunk to a margin that most human beings cannot detect. Both sides have valid points. Both sides also have blind spots the size of a driving range, and the truth, as usual, lives somewhere in the middle of a very expensive argument. To understand the debate at all, you need to understand what actually happens during each manufacturing process, because this is where the real differences begin and where most of the marketing mythology gets its ammunition. Forging starts with a single billet of soft carbon steel, typically a grade called 1020 or S20C in the Japanese designation system. That billet gets heated in an industrial furnace to somewhere around 2000 degrees Fahrenheit until it glows a deep orange. And then it gets placed into a precision machine die and struck with enormous force by a hydraulic press, sometimes exceeding 2,000 tons of pressure per strike. The force compresses the metal and reshapes it into the rough form of a club head in a process that can take multiple strikes across multiple dies. From there, highly skilled technicians grind, mill, and polish the head through dozens of individual steps until it reaches its final shape, weight, and finish. The critical detail that forging advocates always return to is the grain structure. Because the metal is compressed rather than melted and reformed, the molecular grain pattern that exists within the original steel billet remains intact and continuous throughout the finished product. Those aligned, compressed grains create a density and uniformity within the metal that proponents argue produces a distinct vibration pattern at impact, a softer, more refined sensation that travels up the shaft and into the golfer's hands. Casting works through a completely different physical process. It begins with a wax model of the club head, sculpted or injection molded to precise dimensions. That wax model gets coated in layers of ceramic slurry, building up a shell around the wax. The assembly goes into a kiln where the wax melts out and drains away, leaving a hollow ceramic mold. Molten metal, heated to temperatures well above the melting point of the chosen alloy, gets poured into that cavity. Once the metal cools and solidifies, the ceramic shell is broken away and the rough casting is cleaned, ground, and finished. The advantage of casting is almost unlimited design freedom. Because you are pouring liquid metal into a mold, you can create internal geometries, hollow chambers, variable wall thicknesses, and multi-cavity structures that would be physically impossible to produce through forging. You can also use harder, more exotic alloys like 17-4 stainless steel, miraging steel, or tungsten-infused composites that would crack and shatter under the compressive force of a forging die. This flexibility is exactly why cast irons dominate the game improvement market. The designs that help average golfers hit the ball higher, straighter, and more consistently, with wide soles, deep cavity backs, perimeter weighting, and multi-material internal structures, require the geometric freedom that only casting can deliver. Here is where the conversation gets uncomfortable for the Forged loyalists. Multiple independent tests, including robot-controlled impact studies where every variable except the club head is held constant, have shown that when you strip away the visual cues, the brand markings, and the prior knowledge of what the golfer is holding, the ability of even skilled players to distinguish between a forged iron and a cast iron by feel alone drops dramatically. In some blind tests, players rated a premium cast iron as feeling softer and more responsive than a forged iron from a different manufacturer, simply because the cast iron happened to have a thinner top line and a more traditional profile that their brains associated with forged construction. The shaft flex, the grip material and thickness, the ball compression, the turf firmness at impact, and even the ambient temperature all contribute significantly more to what your hands perceive as feel than the manufacturing method of the head itself. That does not mean the difference is zero. There is real physics behind the claim. The continuous grain structure of forged steel does dampen certain high-frequency vibrations slightly differently than the crystalline structure of cast stainless steel, and players with extremely sensitive hands, refined proprioception, and thousands of hours of repetition may genuinely detect that subtle difference when striking a ball under favorable conditions. But the gap between the two is far smaller than the marketing would have you believe. And confirmation bias fills the rest of the canyon. If you know you are holding a forged Mizuno MP20, your brain is already primed to perceive a softer, purer, more refined impact sensation before the club face ever touches the ball. That is not a criticism of the people who prefer forged irons. It is just an acknowledgement that human perception is not a laboratory instrument, and our expectations shape our experience in ways that are extremely difficult to separate from the physical reality of the equipment. The history of how these two processes entered the golf industry adds useful context to the debate. Forging was the original method. Long before modern golf club manufacturing existed, blacksmiths shaped iron heads by heating metal and hammering it into form, and the forging tradition carried directly into the early golf industry. For most of the 20th century, if you wanted a quality iron, you bought a forged one. Casting entered the golf world in a meaningful way in the 1960s and 70s, and the company most responsible for legitimizing it was Ping. Karsten Solheim, the same engineer who later designed the controversial I-2 grooves, recognized that casting allowed him to create perimeter-weighted cavity-back designs that moved mass away from the center of the club face and redistributed it around the edges. This redistribution dramatically increased the moment of inertia of the club head, meaning that off-center strikes lost significantly less ball speed and accuracy than they did with a traditional forged blade. Ping's cast cavity-back irons made the game playable for millions of golfers who had previously struggled with tiny sweet spot forged blades, and the game improvement category that now dominates the equipment market traces its lineage directly back to Solheim's insight that casting was not a compromise, but an opportunity. If you are enjoying this deep dive into how golf clubs are really made, hit subscribe. We break down the equipment, the history, and the business of golf every single week. So if the feel difference is debatable and casting offers more design flexibility, why do tour professionals overwhelmingly play forged irons? The answer has less to do with feel and more to do with workability and adjustability. Forged carbon steel is significantly softer than cast stainless steel, and that softness matters enormously at the professional level. Tour technicians who travel with mobile club fitting vans need to bend lofts and lie angles by precise fractions of a degree to match each player's evolving swing characteristics throughout the season. A forged head made from soft 1020 steel can handle those adjustments repeatedly without cracking, weakening, or deforming the structural integrity of the club. A cast stainless head is harder and more brittle, making aggressive or repeated bending risky and potentially destructive. When your livelihood depends on having your equipment dialed to exact specifications, that adjustability is not a luxury. It is a requirement. Beyond adjustability, forged irons tend to come in blade or muscle back designs with thinner top lines, less offset, smaller overall profiles, and narrower sole widths. These compact shapes give elite players the ability to manipulate ball flight with precision, working the ball left to right or right to left, controlling trajectory on command, and producing the specific shot shapes that different course conditions and pin positions demand. Larger, more forgiving cast designs actively resist manipulation because their high moment of inertia is designed to keep the ball going straight, regardless of what the golfer's hands are doing. For a tour player, a straight shot is only useful half the time. The other half, they need a draw or a fade, a low punch or a high floater, and forged blades give them the control to produce those variations on demand. Tour players also benefit from the immediate, sometimes brutal, feedback that less forgiving irons provide. When you mishit a forged blade, you know exactly where on the face contact was made because the club communicates that information through vibration, sound, and ball flight with total clarity. That feedback loop helps elite players diagnose swing issues in real time, making micro adjustments between shots rather than waiting for video review at the end of the round. That same feedback is exactly why most recreational golfers should not play blades. Knowing that you hit the ball a quarter inch toward the toe is not helpful information when you hit the ball a quarter inch toward the toe on most swings anyway. The cost equation deserves an honest examination too. Forged irons are typically more expensive at retail than cast irons, and there are real reasons for that. The forging process requires premium raw materials, precision tooling, and extensive hand finishing that add labor costs at every stage. A single forged club head might pass through 20 or more individual production steps before it is ready for assembly, compared to a cast head that can be produced in higher volumes with less manual intervention. But some of the price premium also reflects brand positioning rather than manufacturing cost. The word forged carries prestige in the golf market, and companies price accordingly. A consumer who is willing to pay $500 more for a set of irons because they are forged has already made a psychological commitment to the product that transcends the manufacturing reality. Here's the part that neither camp talks about nearly enough. The line between forged and cast is blurring so fast that the debate itself is becoming outdated. Companies like Titleist, TaylorMade, Callaway, and Mizuno are producing forged cavity back irons and forged players distance designs that offer significantly more forgiveness than a traditional blade while maintaining the adjustability and grain structure characteristics of forged construction. These clubs would have been unimaginable 20 years ago when forged meant blade and blade meant unforgiving. At the same time, casting technology has produced irons with remarkably refined impact sensations through vibration dampening urethane microspheres, internal foam inserts, and precisely tuned weight distribution systems that engineer the feel rather than relying on material properties alone. Some of the smoothest feeling irons on the market today are technically cast products. Multi-material construction has pushed the convergence even further. Several major manufacturers now produce irons with a forged carbon steel face welded or bonded to a cast, stainless steel, or tungsten body, combining the impact properties of forged material with the design freedom and weight optimization of cast construction. The Ping i230 irons, the TaylorMade P770 series, the Callaway Apex line, and the Srixon ZX series all incorporate elements of both manufacturing processes in a single club head. When the iron in your hands is literally part forged and part cast, arguing about which process is better starts to feel like arguing about whether the engine or the transmission is more important in a car. The reality is that both manufacturing methods produce excellent golf clubs in the current era, and neither one is inherently superior for every golfer in every situation. If you are a low single-digit handicap who wants maximum feedback and shot shaping ability and adjustability from your tour technician, forged irons still make the most compelling case. If you are a mid to high handicapper looking for forgiveness, distance, and consistency from imperfect swings, cast irons with modern engineering will almost certainly serve your game better. And if you are somewhere in between, the growing category of forged cavity back and player distance irons offers a legitimate middle ground that did not exist a decade ago. The answer was never really about the manufacturing process itself. It was always about matching the right design characteristics to your swing, your skill level, and your goals. The word stamped on the sole of the club matters a lot less than how that club performs when you stand over the ball. If you want to understand why one Japanese manufacturer has quietly built the most respected forged irons on the planet, check out how Mizuno quietly built the best irons nobody talks about. And for a look at how Japanese craftsmanship stacks up against American mass production across the entire equipment spectrum, watch why Japanese golf clubs destroy everything made in America.